Hello friends, welcome to online school. In the previous video, I had a look at of how to differentiate trigonometric functions with multiple angles. So let's get to how to differentiate trigonometric functions with higher powers. And after at the end of this, I think I'll put like some trial questions, and then if at all anything fails to come out, you can comment in the comment sections. Now, so let's first try to look at how to differentiate trigonometric functions with higher powers. Now then here, let me work out the one of y equal to cos squared x, and then after that, you hope you'll be able to work out the one of y equal to sine squared x. And so let's begin. So we have our function as y equal to cos squared x, like that. And so we begin by adding small changes. So we shall say that y plus change in y equal to cos squared of x plus change in x. Now in this case here, you also note that it is not cos squared x plus change in x like that, but rather it is this way around. And so after adding small changes, we know that we can subtract the two equations. So we shall have y plus change in y minus y equal to cos squared of x plus change in x minus cos squared x. And then we know that this one here, it will simplify to change in y equal to cos squared of x plus change in x minus cos squared x. Now after that, we have this expression here, and then so it's not stated anywhere in the factor formula. So what do? We are going to simplify this part here using the difference of two squares. And then from the difference of two squares, we have that a squared minus b squared, this will equal to brackets a plus b, and brackets a minus b, like that. Now, so after knowing this, so we take our cos of x plus change in x to be the a, and then we say that let a be cos of x plus change in x, such that when we get it as a squared, we shall have a squared equal to cos squared of x plus change in x. And then we can also have our b equal to cos x, such that when you square the b, you'll get also this side cos squared x. And then so let's try to simplify that using the difference of two squares. So we shall have our change in y equal to a plus b, and then in that case we shall have cos of x plus change in x, or let me write it like in this format. We use a different set of brackets. So we shall have our first bracket here, and then here we shall have cos of x plus change in x as the a. We shall have cos of x plus change in x, then plus the b, which is cos x, right, like that. And then so this is the first bracket here, and then we shall also have cos of x plus change in x minus cos x, right, like that. And then so after getting to that step, we can apply the factor formula. We happen to see that we have cos alpha minus cos beta as this part here, and then we have cos alpha plus cos beta as this first part here. So how do you simplify that? And then we know that we shall have here change in y being equal to, so cos of an angle plus cosine of another angle, we get 2 cos. So here we shall have 2 cos of alpha plus beta, whereby it is going to be x plus change in x plus x, and then we have the whole of this being divided through by 2, like that. Then cos alpha minus beta, so we shall have x plus change in x minus x, even this one here being divided through by 2. So this is our first bracket here, this bracket here. So let's get to the second bracket, and then this one we have cos minus cos, and we know that this is negative 2 sine, the sum of the two angles. So it is going to be x plus change in x plus x divided by 2, then sine the difference of two angles, x plus change in x minus x, and even this one here divided through by 2. Right, so after that step, we can simplify each of the brackets. And then in this case here, we shall have our change in y equal to this first bracket here. We shall have 2 cos x plus x. This will give us 2x plus change in x plus change in x divided by 2, like that. And then cos x minus x, we shall only remain with change in x divided by 2. So this is our first bracket. And then we get to the next one, this one here. We shall have negative 2 sine of 2x plus change in x over 2. Change in x over 2. Then sine change in x over 2. Right, like that. And then so from there, you can see that this 2x plus change in x over 2, it can simplify to x plus change in x over 2. And then the same as this part here. And then so from there, you can divide through by the change in x. And then we take the limits. So this first part here, we shall have change in y over change in x. And then even this other side, we shall have the whole of this part here divided by the change in x, like that. And then so from that, we know that our dy dx, it is equal to the limit. Dy dx is equal to the limit of change in y over change in x as change in x approaches 0. So we can write it here and we say that dy dx is equal to the limit as change in x approaches 0 of change in y over change in x. And then so this one here, it will give us something like this. The limit as change in x approaches 0. Now you note that this is negative 2. It can multiply these two here to get negative 4. So you are going to be having negative 4. I've taken this negative to this side. We shall have negative 4. Then we have cos x plus change in x over 2. I've simplified this one here. Then we also have cos change in x over 2, like that. Then we also have, we can even open these brackets here, and then we get to sine of x plus change in x over 2, like that. And then finally sine change in x over 2, like that. So then we have the whole of this being divided through by the change in x, and then we can put it here that divided by the change in x, or like that. And now once we get there, now this one here, we are going to use the limits, the knowledge of taking limits. We happen to find that we know that sine of a small angle in radians, it will be approximately that very angle. So now for that case, let's do this. As you take the limits, this part here, it will tend to 0 because change in x over 2, because of the change in x over 2. And then we shall have like something of the format 0 over 2 to give us a 0. And then we know that the limit of cos of change in x over 2, as change in x is approaching 0, this one here, it will give us a 1. And then this part here, we shall also have it going to 0. Remain with sine x. Even here, we shall remain with cos x. And then here, we shall be having something like change in x over 2, it will be getting to 0. This angle will be getting much, much smaller as change in x approaches 0. So we shall have like something like cos of 0, which we know that it is a 1. And then in this case here, let's evaluate it with this. So sine of a small angle in radians, it will give us this very small angle. Let me try to work it out here. That sine of change in x over 2. And here it will approximately get to change in x over 2. But then remember that here you have this change in x, so it will be like it's being divided through by this change in x, and then it's kind of like we shall only remain with a half, of which the half here, it can reduce the negative 4 here to a negative 2. And then so we shall get to our dy dx being equal to, remember this is going to be reduced by this a half here to get negative 2. And then this cosine of x plus change in x, this one, it will reduce to 0 and we shall remain with only cos x. And then this one here, it will be like, it's the limit of this, it will give us a 1 because change in x over 0, change in x over 2, and then change in x approaching 0. It will be like we shall have cos 0, which is a 1, so times 1. And then times this part here, which was giving us a half, which was also evaluated to a 1. And then remember, we have this also. We have this part getting to 0. We shall have times sine x, and then times 1, like that. So we shall have our dy dx being equal to negative 2 cos x sine x. And then this is the derivative function. This is the derivative function of our function we had in the first place. So now after doing that, we have the derivative function. And then these are the steps we followed. We had y equal to cos squared x as our function, trigonometric function, which was, we had a higher power. And then this is the workout we've gone through. So finally, we have negative 2 cos x sine x, which can also be simplified further using the knowledge of trigonometry. And then so after that, let me try to put here some trial questions from all the sections that we had a look at. So we had a look at trigonometric functions with single angles, and then from there, hope you can be able to try out find the derivative function of the function y equal to tan x. And then a tip here, you can first evaluate this tan x to sine x over cos x, and then you use the rest of the steps, the previous steps we've been using in the previous videos. And then you can also have y equal to sec x. These are trigonometric functions with single angles. And then so you can also have from multiple angles how to find the derivative of our function, like y equal to tan 2x. Then we can also have from higher powers how to find the derivative of y equal to sine squared x. So you can try out those questions, and then if anything fails, you can comment in the sections below, comment sections below. And then so in the next video, we shall be looking at another section of differentiation.